Hello friend, welcome to my YouTube channel Electrical Boost. In our last video, what is analog circuit and how it differ from digital one. Today we will go one step forward. Today we understand two fundamental type of circuit. Two fundamental type of circuit, that is DC and AC circuit, and how they differ from each other and what are the behavior of those two circuit in our electronics application. Okay, this is called basic. In the basic circuit, every analog and a digital electronic circuit, we are going to use DC and AC circuit. Okay, let's start with DC circuit. DC circuit. In the DC circuit, basically, what is DC circuit? First we know what is DC circuit. First we know what is DC circuit. What is DC circuit? Okay, what is DC circuit? Let's start the basic. DC means, already know DC means the direct current. Direct, that means what are the source, in the circuit, the current flowing in one direction. The direction cannot be changed. Suppose with the time interval, this current will flow in one direction. The magnitude you can see at the time, anytime, 0 time, same one direction, and also this something time, t equal something, t equal to x or something, here also same. That direction always same. If let's consider one circuit, this is one circuit. Here I connected one battery. Battery is the source of DC. Okay, here we are going to make DC circuit. Just one basic circuit. Later we go for the what are the important circuit, how we are going to use in our analog design case. Okay, this is one LED, this is one resistor, or I represent name is R, and this is the one LED. Okay, if we apply one voltage, suppose some voltage I apply 3 volt or 5 volt, any volt I can apply, the current will flow. The current will be flow from this positive terminal to negative, positive to that resistor and to LED. If you observe this in video or simulation diagram, there you can see the LED is continuously flowing, that no blinking. That means it continuously 3 volt is given. That is particular simple DC circuit. You can see how it will visible, how DC will behave with the LED. Okay, the relation between, you can see, if I draw one circuit, that only suppose I take voltage and with resistor, how it will behave with this circuit. Always in DC case or AC case, that well know about the Ohm's law, how will is proportional to this one, you can check. Okay, first this is the voltage, this is the resistor. Suppose the R value is 2000 ohm, this is suppose 5 volt. According to the Ohm's law, V equal to I into R. For example, you can take this 5 volt, then here current is I equal to V by R. That means 5 by 2000, that is equal to 2.5 milliampere. Okay, you can consider. Okay, DC, this is simple. I will show how we'll calculate current by using Ohm's law. You can go my previous video where you can get this all thing details Ohm's law. Okay, basically for our consideration, DC circuit use DC circuit or DC supply use almost all electronics cases, electronics circuit. You can consider, suppose you go for where the let me consider like that microcontroller. In microcontroller, almost we are all using some DC voltage or power to DC volt, 3.3 volt and suppose 5 volt and 15 volt and like this. Suppose not 15 volt, we are just 3.3 to 5 volt maximum we are using. All are DC. In suppose in amplifier cases also, suppose you can amplifier, in DC amplifier you can just for the bias we can take a DC set point. For biasing we set the DC set point. Okay, later we discuss while amplifier how the DC will use, but now only we discussing how DC circuit will going through. Okay, next you can come with an AC circuit. Next we can go for the AC circuit. Basically overall we are going to AC circuit. Basically you can know AC circuit is like this. It can behave, it can like this, it behave. Okay, this is the time, this is the voltage. Here you can see in the AC circuit the whatever the voltage or current, it can change with time. Direction it will change. First is positive and sometime after some time it will negative, it will come, so that it will changing, so that we can take as here frequency available. In suppose in this way, from the voltage grow from positive to negative, here positive to negative. Okay, and back again, suppose we continue this one, again it will positive continuously it will come. Okay, this change repeatedly many times, so that it called frequency. Suppose one cycle you can F equal to 1 by T. If one cycle, how much time once complete one cycle, how much time will take, that is called frequency. Okay, time per second, you can tell the time per second. Okay, one cycle completing, how much time it will take. Okay, that is called frequency. You can represent this Vt means voltage with respect to time, it will Vm. Here we get taking sine up, so that sine omega t. Omega is the angular frequency, that is omega will 2 pi f. For details you can go another video in the description, you can take it this one for details. AC. In this AC circuit, all components like that resistor, inductor and capacitor, it behave differently. How? In the resistor the current always in phase, but in inductors current always lag, and in the capacitor it will lead. In our, you can ask where we can use this AC in our circuit. For the communication having some frequency, that is also AC, where the frequency will come, that is called alternating in nature. Okay, in the communication system and also in power section, we are using AC. In our domestic power supply, that is also AC with 50 Hz, but for higher communication frequency, radio frequency, that is some megahertz. Somewhere in the circuit also you can some signal, it is also AC form come. In the overall you know that both is analog, so DC and AC use our analog circuit design or any type of electronic system. Okay, then you go for what is the difference between AC and DC circuit. Here I make one table, small one, that is not different, comparison between AC and DC circuit. Here the direction already you know, it will one direction it can flow and it is alternating in nature. Frequency, in case of frequency you consider DC always 0, it is not changing. No? Frequency you know the 1/1 time. One cycle complete how much time it will take, that is called frequency. In DC case it is 0. Okay, and in AC case this is alternating, so that it is any frequency, means some frequency it will come. In our, suppose in case our domestic electricity you can call as some 50 Hz it coming for our domestic power supply. But in our electronics case, some radio frequency it come under some megahertz. Okay, some noise also consider, after that we will filter some noise also, some frequency it come. Okay, something, and some communication some frequency also coming. And the common source for DC is battery, or you can solar cell also. Basically cells are the common source for DC, and the AC you can consider as alternator or generator, or from this DC also you can convert to AC, or AC to also DC you can convert, that is also rectifier, inverter. We can discuss later, for more design will go. Okay, this is overally DC and AC. You can, from this comparison you can know, in our electronics cases all this type, both two are most important. So that first we know what is the fundamental between those two. First we know the fundamental. Okay, in this video we discuss about the fundamental of these two things. Okay, today for this this topic. Okay, thank you for watching this video. Please like and subscribe my channel. In our next video we are going to discuss about the component, that is passive components and active component. In our up to now we are discussing what is analog circuit, and second video we are discussing between the difference between the DC and AC circuit. Next we are going to about the component. After component we are going to make one by one circuits. Thank you again. Please like and subscribe.